Hello, this is Mrs. James, and today I'm talking about what you missed on Friday, March 14th, 2014. This includes all my sophomores who went home after taking the OGTs, as well as any of my freshmen who were sick that day or who were absent that day. This would be in my physical science class, not my physics class. Also, it does not include my fifth period. My fifth period did a different activity, and I will catch those students up on the small amount of information that they need Monday, before we start our work. So Friday, March 14th. First thing that we did is I gave my students just a little warm-up scenario. If you need to pause this at any point in time, please do so, and then give this a try yourself. So we gave a situation where somebody, Gina, drops a toy with a parachute out of a very high window with a lab pro watching it so that she can see how far away it's fallen from the lab pro. In other words, how far away it is from the window in the down direction, and also at the same time measuring the time of that fall. And this was the data that I gave. So again, if you need to, pause this, and what I'd like you to do is draw a distance versus time graph. Now I don't need the numbers, all I need to see is the rough shape of the line, and also a free body diagram, and that's the thing with the arrows. So in just a second I'm going to switch the page and show you the answers. Alright, here is our distance versus time graph. The object is accelerating, so we have a curved line. Here is our free body diagram. The down arrow is the force of Earth on the toy, and the up arrow is the force of air resistance on the toy. Next thing that I did is I had students quote Newton's first law of motion the right way, which it replaces the word outside with unbalanced, so it goes like this. An object at rest will stay at rest. An object in motion will continue at that velocity until acted on by an unbalanced force. I then explained that the next thing that I should do would be to talk about free body diagrams when an object is on an inclined plane, but we're going to wait and we're going to cover that this upcoming week instead. Since there were so many people absent, I didn't want to cover something that's as tricky as this is without everyone being there. So instead, we worked ahead to Newton's second law of motion. Students who learned this in junior high learned F equals ma. We're going to make it a little bit more high school appropriate by adding the word net. And net just means that it takes the unbalance into account. So here's an example of a problem being solved with F net equals ma. Mrs. James is pulling a wagon with 35 newtons of force. If the wagon is accelerating at 2.3 meters per second squared, then the friction between the wagon and the ground is 2.3 newtons. What is the mass of the wagon? Now the important thing to realize here is that I am pulling the wagon with 35 newtons of force, but friction is resisting with 2.3 newtons. So not all of my force is able to accelerate the wagon. Some of my force is busy fighting this friction. And it's only the rest of the force, so 35 minus 2.3 newtons, that's actually responsible for accelerating the wagon. So what the net means here is the difference between the 35 newtons and the 2.3 newtons. So the net force takes into account the imbalance. Since my pull and the friction were acting in opposite directions, then we subtract the forces. If somebody would have been helping me pull, so let's say that Sally was also pulling on the wagon with 3 newtons of force, we would add together these two forces and we would subtract this force from it to find our net force. So using our familiar problem solving technique, we identify what we know, and our force is 35 newtons minus 2.3 newtons, that's the friction force, for a net force of 32.7 newtons. Acceleration is 2.3 meters per second squared, and we're trying to find the mass of the object. F equals ma equals our equation, and we rearrange this for mass equals force divided by acceleration. Here's our net force, 32.7 newtons divided by 2.3 meters per second squared. Here's our answer, written with the correct sig figs, is 14 kilograms. Alright, and we will on Monday be doing a worksheet covering the same material in class. And that's all you missed since we only had a 20-minute period, so I need you to be ready to jump in and start being able to solve some of these simple F equals MA problems on Monday in class.